thank you everyone for taking the time to participate in this briefing today. I'm going to hit some of the high points of the key messages. Emilie is going to go through and hit some of the important facts about the state of the grid. So with that, we'll proceed to the presentation. As a reminder, New York ISO prides ourselves in our ability to independently maintain strong reliability, administer fair and open competitive electricity markets, as well as providing factual information to stakeholders and members of the public media and to the industry. Next slide. Part of our key challenges we're seeing in 2020 with this new power trends, obviously the COVID-19 pandemic has altered significantly the way that people work and live their lives, and has resulted in challenges and changes to the electric sector. So one of the things we've tried to be mindful of is to keep our eyes on some of those demand patterns and how it might influence and change the way the markets work, or change the way in which we use and consume electricity. But we also are very, very cognizant that the goals and the objectives of the industry have not changed. We're going to maintain tight vision on our on what we need to do to get New York State to those goals, and we continue to maintain the core values and the core mission of the organization through the pandemic. We also are very mindful of the challenges and the goals, the very aggressive climate goals that New York State has adopted through the CLCPA, and we maintain our tight focus on helping to achieve those goals. We remain committed to markets as the most viable and effective means to meet the goals in the most cost-effective manner, and we remain committed to maintaining the highest level of reliability really in the industry within New York State. Next slide. When we look at some of the key trends that we're seeing, obviously new technologies are impacting the industry at large. It's a very exciting time in the utility industry, whether it's new renewable projects, whether it's wind, solar, distributed energy resources. It's really changing the way how energy is produced and how it's moved and how it's used. So we're very, very mindful and excited to be participating in the industry at this time. Public policies are increasingly becoming more impactful to the industry, and we participate fully with New York State in terms of understanding what the policies are, and adapt our practices and our markets and our models to be able to support those policies. Infrastructure is becoming increasingly important, specific to the infrastructure of transmission, and we remain very, very bullish on the need to be able to build out the infrastructure, and transmission is going to be a very, very important part of being able to move power from where it's generated to where it's consumed. And we continue to study and promote the notion that we need additional infrastructure. We're also looking at mindful of the economic influences. This is a very, very challenging time, both in terms of the pandemic and the impact that it's had on society. So we at the New York ISO are very, very committed to looking at the most cost-effective way of being able to both hit the goals and to deliver power to consumers. It's an important part of our mission, and coming up with the lowest cost and leveraging markets and the competitive nature of markets to come up with the lowest cost delivery of that commodity is critically important. Next slide. If you go through the report, there are some very, very key initiatives that we have underway. First and foremost is our proposal to implement carbon pricing, and we look at this as the most effective, viable means to attract the right kind of investment for renewables that's going to be so important and necessary for New York State to hit the clean energy goals. And we remain committed to promoting that. We think it's using a cost of carbon societal cost of carbon embedded in the markets is going to be the most effective and cost-efficient means to be able to hit those goals. And we'll get into a little bit more about that later in the report, but that's still a very, very important initiative in our plan. Markets in general, I think we recognize that the markets need to continue to evolve. The basic premise and purpose for when markets were created 20 years ago have done a tremendous job of hitting the goals, driving down costs, and incentivizing the right kind of development. But when you start thinking about how the policies are changing and increasingly how renewable, carbon-free resources are so central to the achievement of those goals, we recognize that markets need to continue to evolve, and we're committed to that. And we think we've got a pretty good plan for how those markets can be modified. Also thinking about, looking to the future. There's a stronger element of planning that's involved. Traditionally, we look at planning for reliability and we look at planning for economic benefits, but increasingly we need to look further into the future and start to model what this system is going to look like 20, 30 years into the future as we migrate towards a carbon-free system. And our planning team is in the middle of that, and a lot of what drives the initiatives within the report are being influenced by that planning and the reports that come out of that planning process. So that's going to be an important element as we try to establish a leadership role to help the industry migrate to where we need to be. And a lot of what's included within the report this year is driven by those planning models. So that'll continue to be a important area of focus for the New York ISO. So that's the high point. I'm going to turn it over to Emilie Nelson to walk us through the stats of where the grid is today, and then I'll be back at the end.
Thank you, Rich. Good afternoon, everyone. I hope everyone is happy and healthy and doing well today. I'm going to move through fairly quickly a series of slides to give you a better sense of the current state of the grid, and also identify some of the factors that we are mindful of that are shaping how the grid will transform in the upcoming years. So we continue to highlight the theme of the tale of two grids, where energy from upstate clean energy resources is constrained by the transmission system limitations, really from delivering power to the load centers in Southeast New York. If you look at the slide that's on the WebEx currently, you'll see that 88% of the energy produced upstate came from zero-emission resources in 2019, relative to downstate that received only 29% of its energy from zero-emission resources last year. The power trends for 2020 describes the analysis that's underway to further identify transmission constraints that limit clean energy delivery, which will certainly be very important to ultimately achieve the clean energy goals for the state. Moving on, I'd like to show you some of the seasonal electricity demand patterns that are managed today. Certainly, the NYISO's commitment to reliability includes reviewing and managing some of the variation that occurs between electric supply and demand on a daily and hourly basis, as well as a seasonal basis. One thing to be mindful of is that we continue to be a summer peaking system. You can see that in the slide with the dark blue line. That means that our overall electricity demand is still driven by those hottest days in the middle of the summer, where everyone has their air conditioners running, and you're really trying to address the heat of the middle of the summer. So that is still the focus as far as overall power system management. One aspect of being able to meet that demand is a concept that we refer to as resource adequacy. And on the next slide, you will see some of the fundamentals with respect to how we make sure we can meet that peak summer demand. And that concept is really that you need to solve for the expected maximum load for a given year, and you need to have a reserve margin in addition to make sure that you can deal with any unexpected events, what we refer to as contingencies. The NYISO works with the New York State Reliability Council each year to determine the appropriate level for that reserve margin. We refer to that as the IRM. As discussed in Power Trends, in proposing the IRM for the current year, the Reliability Council noted that a primary driver was load forecast uncertainty tied to weather conditions, which is something that will become more and more important as more of our resource base relies on the sun or the wind, really these weather conditions, to drive their power output. And thinking through that, we'd like to show you a graph that we refer to as capacity factors. And if we get to that slide, what you will see is that not all energy resources have the same attributes. Not all energy resources are the same. The output of some of them can be readily controlled by operators, while others are dependent on those weather conditions I just mentioned. So a challenge for us looking into the future will be having the right mix of dispatchable resources available to meet load and while also leveraging the attributes that the renewable resources bring into the grid. In New York, we are able to leverage a very diverse resource base to meet New York's energy needs. Moving forward, we see that one of the ways that we're able to determine the set of resources that can most efficiently meet the state's energy needs is by leveraging the power of wholesale markets. So the NYISO's markets have worked in tandem with state energy and environmental policies, certainly to achieve the clean air benefits for New Yorkers that we're all working so hard to achieve. You can see that from the period of 2000 through 2019, emission rates have dropped significantly, but there certainly is a lot more to do. So going on to the next slide, you will receive a better view of what we ultimately need to achieve, the mandates that we are working toward for New York State. On the bottom of this graphic, you can see the in-state production for 2019, and at the very bottom of the graphic, you see the total renewable energy production. You can see that it dips slightly. That's the dark green band. And you can see that it dips slightly throughout the summer months. And that is because there are sort of seasonal patterns, as I mentioned earlier, that we must manage to. At this point, what we see is that wind production does fall somewhat during those summer months. And what I think is most interesting about this slide is you can look at the energy production from renewables, and you can look at the energy production from other zero-emitting resources relative to the ultimate mandates that we need to achieve, which are identified with the straight line up at the top of the graphic. And in the next several years, we will be putting more and more of the tools in place to be able to achieve the 2030 renewable goal of having 70% of our energy production supported by renewables, and then ultimately in 2040 having 100% of our electricity supplied by zero emissions resources. Moving on. One of the responsibilities of the NYISO is to determine how to build out the tools to reliably integrate intermittent resources. So an important area for us is integrating behind-the-meter resources such as solar. At this point on the system, you can see that we have approximately 2,000 megawatts of behind-the-meter solar installed across the state. And part of our role, even for behind-the-meter resources, is making sure our operations team has the tools that will allow them to manage the overall bulk power system efficiently. So we have developed forecasting processes so that we can better understand and manage around some of the variability of the behind-the-meter solar resources. And this is a good example of how we approach the question of evolving the grid while still meeting the high standards of reliability that we must satisfy for the state of New York. Moving on to the next slide. Another example of this is with respect to wind energy integration. At times, there are constraints on the transmission system that limit the ability of wind resources to deliver energy to customers. So the NYISO has the ability to really forecast the wind production, just as I mentioned for solar on the prior slide. And we think an important aspect of what we're doing with respect to wind and energy integration is not only on the operations timeline, but also on the planning timeline, to be able to communicate that we are experiencing these curtailments on the system, and to be able to communicate how that can be addressed. So ultimately, the wind energy production can be leveraged to serve customers. And this is some of the work that we are exploring and communicating through some of our planning studies this year. Moving to the next slide. A factor that is really influencing what will be needed to reliably operate the grid going forward is the electrification that is expected across the state. So the electrification of transportation and building heating systems will certainly change the demand patterns that we need to manage. And the NYISO is studying the potential impacts of this electrification. Ultimately, this information will allow us to develop the market design and further the planning processes necessary to support this transition while meeting reliability. There is one sort of acronym that you see in the slide here, and it's EVs, which of course is electric vehicles. So as more and more electric vehicles come onto the system, the time that those vehicles are charged will be something that will impact both our peak loads that we need to manage, as well as the overall demand on the system. So that's a great example of a behavioral trend that could really impact the day-to-day work that we do here at the NYISO. We'll dig a little bit deeper into the peak trends on the next slide. So this slide certainly is very future focused. You can see where we are right now in 2020 and last year in 2019. We had a peak of just over 30,000 megawatts. But as you look into the future out to 2050, you can see that that peak load that will need to be managed is a function of electrification, as I just mentioned, and certainly the resources that come onto the system in order to meet that peak will be very important to us. So what forecasters typically do is they build out scenarios and they consider how different factors can influence whatever variable it is that they're exploring. And you can see that depending on the assumptions that are made, the ultimate peak that may materialize looking out into the future can potentially reach a much more substantial level. So understanding the implications of electrification will be very important to us going forward. One of the tools that we may leverage in order to manage these peaks is shown on the next slide, and that is energy storage and how energy storage may be built out onto the system, which is referenced in the capacity that is shown here in the graph. And it'll be an important element for us to align what the available resource base is, and certainly to take advantage or fuller advantage of the output of intermittent resources such as solar and wind to meet the demand, which may not be coincident. So as more storage is built out onto the system, it will help us better align the output of intermittence in order to meet those demands. So next, we'd like to go into some of the public policies that are really influencing how the grid will evolve in the upcoming decades. So if you go to the next slide, we have a very abbreviated graphic which describes the objectives of the Climate Leadership and Action Act. So, of course, as we well know, we need to achieve 70% of energy production through renewables by 2030. That includes integrating very specific resource types. The mandates include 9,000 megawatts of offshore wind, 6,000 megawatts of distributed solar, and 3,000 megawatts of battery storage. So when you think of the power grid today relative to the achievement of the Climate Leadership and Community Protection Act, we see that overall these policies will and should drive new technologies to enter into the grid, and really being mindful from the NYISO's perspective of how to improve our processes, improve the pace at which these resources can be considered, and things such as our interconnection queue will be very important to fully achieve this vision. And if we go to the next slide, this once again provides a view of the starting point, if you will. Where are we as of 2020 from a capacity perspective, and then from an energy production perspective on the next slide for 2019. But sticking first with this, actually, if you would just take one step back to the generating capacity, you can see that something new that we've added into the visualization of the current capacity mix is really an outer ring on each of these graphics, and it shows from a capacity perspective which resources are fossil-based versus would fall into the category of zero emission. And we've continued to portray what that looks like for the state overall, and then also provide an upstate and a downstate view on the right-hand side. So you can see that upstate, with the green outer ring, you have a significant portion of zero-emission resources, whereas downstate, the installed capacity, as represented with the brown ring, is still predominantly fossil-based. Moving to the energy production on the next slide, this is, of course, backwards looking because it's actual energy production. And rewinding to 2019, you can see that fossil fuels make up only 39% of the state's overall energy production, but that production is concentrated in southeastern New York. So once again, it will be very important to connect the renewable resources with the load centers through transmission in order to fully realize the objectives that we have for the state with respect to the climate leadership and community protection. Moving to the next slide, I think I will hand it back to Rich to close out the slides. Thank you.
Thanks, Em, and everybody. Obviously, recognizing the current status of the grid and what we have in place, and appreciating the very aggressive goals that New York State has. Obviously, there's going to be some big changes needs to be brought about in terms of how we achieve those goals, what the supply stack looks like. And we look at this as really as a grid in transition, and we're looking at not only how do we maintain reliability of the system as the grid radically changes, but how do we provide the right kind of pricing signals to drive investment of the right type of resources and in the right locations. And we look at markets as being central to that and in a very important component to help lead that transition. Going to the next slide, again, just to reiterate, we talked about this a little bit, but carbon pricing we view as the most viable mechanism to do that as quickly as possible and as cost effectively as possible. And essentially, how this would work is we would partner with New York State. New York State would establish what that social cost of carbon is. We would take our very, very successful market systems and embed that into the actual dispatch. So not only would the most lowest cost production schedule be generated, but it would also drive toward a cleaner schedule. So power plants that are cleaner would actually get paid more, and power plants that are dirty would end up paying that back. So that way it would drive not only the best value for consumers, but it would also drive and create an investment signal that we believe would lead to more rapid deployment of carbon-free, low-carbon resources, and it also would do so with the locational signal that's so valuable to get the right kind of reliability signals so that resources get built not only when we need them, but where we need them. So carbon pricing, we think, is probably the most important component to help use the market as a tool to drive towards that new renewable zero carbon future that the goals are targeting. Onto the next slide. We also recognize that technology and innovation is going to be vitally important to be able to hit the goals that we've established, that New York State has established. When you think about wind, solar, and battery storage, I think that those technologies can very capably and ably get us to that 70% renewable target by 2030. But when you start thinking about a zero carbon electric system, which is stipulated in the goals for 2040, we're going to require a whole lot more innovation and new technologies that, quite frankly, are not completely commercially available yet. And we think that the market signals can help drive that innovation, whether it's for distributed resources, whether it's for new technologies that could help us get to that zero carbon infrastructure. We think that the markets are the most viable, effective means to do that. Onto the next slide, you can kind of see the progress. This is a view into our interconnection queue, and you can see that there are lots of projects that are in the early stages of development, and so we think that the market signals that we're presenting, number one, are attracting the right kind of resources that we need now, and would only serve to accelerate that into the future. And then finally, before we get to questions, just on the next slide, just thinking about transmission again. Emilie described some statistics with respect to wind and the constraints that we see on the upstate system, where today at the levels of renewable wind resources that we have deployed today, we're already starting to see some curtailment, and we think that's going to continue to be a bigger and bigger problem, where we're just not going to be able to deliver those renewable resources to the load centers in New York City and Long Island unless we upgrade the transmission infrastructure. So we have projects underway today in Western New York that help maximize the amount of hydropower we can get out of Niagara, as well as the AC transmission project, which is going through siting right now, which will help increase the transfer capability of the backbone, which would allow us to move more power from upstate to downstate. We're going to have to look at additional transmission upgrades that will help us get some of those renewables, both from the areas where they're installed to the backbone, and to increase the capabilities down to New York City. And that's going to continue to be an important part of our planning and the messaging around how we deliver these renewable resources to the load.